2 is not a prime number in the Gaussian integers. These are essentially complex integers. They take the form a plus b times I, where I is the imaginary unit and a and b are both integers. Every point in this grid represents a Gaussian integer, where the horizontal part is the real component and the vertical part is the imaginary component. A Gaussian integer is prime if it is not the product of any two other Gaussian integers. Here are all the Gaussian primes. Interestingly, the prime number 2 is no longer prime in the Gaussian integers. The two numbers that multiply to 2 is 1 plus I and 1 minus I. In fact, any integer that is the sum of two squares is not a Gaussian prime. To see this, just multiply the numbers a plus bi and a minus bi. Multiplying them gives us this expression, where the middle two terms cancel, and the I squared makes this negative a positive. Here's a nice geometric interpretation. Draw a circle with radius square root 2. If this circle intersects any Gaussian integers, then 2 is not prime. This is because any number on this circle, multiplied by its mirror image below the x-axis, corresponds to adding their angles and multiplying their magnitudes, which would give you the number 2. This geometric interpretation shows us that the primes 5, 13, and 17 are all not Gaussian primes. This is just the beginning of the interesting world of Gaussian integers.